All right, we're going to actually finish the unit the way I've structured this unit. I mean, sometimes it's part of a bigger thing, but doesn't matter. The point of this particular set of notes is that we're going to be graphing linear equations. So the gig is up, man. I'm telling you now, if I say linear equations, these are all going to make straight lines, right? That's what linear means. Remember, it means a straight line. And so what we're going to be doing is sketching the graph of each equation and then looking at the X and Y intercepts of each graph, and we're going to write them in ordered pair. So we're going to start talking about X and Y intercepts as well. It's like the basic element of function analysis, and so you can tell a couple things. Then in the next unit, we'll get into slope because I'm separating that out. But that's another way you can analyze linear functions. There's really only two things you can look at for linear functions: is slope and intercepts. But that's not the point. Point is, we're going to be sketching graphs. So I have 4 different equations that are going on, and I'm already giving you the gig, right? It's linear. It means it's going to make a straight line. Bam, or bam, or bam, something. Either way, it's going to make a straight line. So what does that mean? It means a whole bunch of stuff, and we'll get to that. So 4 different equations. Let's graph each one, and then we'll talk about the intercepts, both the X and Y intercepts. So we have this first equation, 3x plus y equaling 0, and we're going to sketch a graph. Now we already know it makes a straight line. So what we can do is make our xy table, and basically how many points do we need? If you watch the guaranteed pass notes or the previous notes on graphing, I want 5 ordered pairs, right? But I only need 5 ordered pairs if I don't know what the graph looks like. In this case, I already know the graph looks like a straight line. So realistically, I only need 2 points. I'm going to give 3 anyway, but I only need 2 points. Okay, so but I'll give 3. So let's say we have, maybe -2, 0, and +2. Okay, so we're going to look at that, and then I'll talk about something in a second when it comes to intercepts. So we're going to make a table of values, and we're going to see what we get for y. All right, so this is just like previous notes. Everything else about the equation stays the same. We're just substituting in -2 for x, and then we're going to see what we get for y. Okay, so I'll substitute in some stuff there, and then crunch some numbers, solve for y, see what we get. So if I have -6 plus y equaling 0, y of course equals +6. So if I plug in -2 for x, I get +6 for y, and then the same thing occurs for each thing. So now, x being 0, well, I'm going to show the work for that because it's something kind of cool I'll talk about in a second. So we have substitute 0 in for x, and see what we get for y. So if 0 plus y equals 0, clearly then y equals 0. Well, that's neat. And then that's something special. I'll talk about that in a second, and then finish up the thing. And then you can show your work and all that stuff. And if you plug in 2 for x, you would subtract 6 on both sides. You would find out, well, we get -6 for y. So now we have our 3 points. We can start graphing it. But let's talk about x equaling 0 for a second. X equaling 0, what's interesting? If we just focus on that particular ordered pair, this is an interesting ordered pair. So let's mark that as interesting because it's a thing. It's interesting because if x is 0, what we're actually getting is the y-intercept. So when x is 0, we find the y-intercept. How cool is that? I think that's pretty cool. You should too. Remember, if you're bored, it ain't this. This stuff is awesome. You're the problem. Anyway, so that's what's interesting. If x is 0, we find the y-intercept. Is that true? Well, let's take a look. Let's graph what we got, right? So we make a quick ordered pair. So you can tell my y-axis I'm going to need -6 and +6, right? Can I count 1, 2, 3, 4, 5, 6? I'll go one more, 7, just to make it look pretty. And then in the negative direction, one more to make it look pretty. I only need 2 on the x and y. But remember, you want to make them evenly spaced. So now we have our little graph, and then we start filling in our ordered pairs. So we have -2, +6. There's -2, +6 is up here. and then positive 2, negative 6 is down here. So we have those 2 points. But remember, like we said, what's interesting? What's interesting is that if x is 0, we have our y-intercept. Here's the y-axis. What the y-intercept is that point that crosses the y-axis. So where is this graph going to cross the y-axis? Is going to cross at 0. So that's pretty interesting. We now have the y-intercept. The y-intercept then is 0. That's what that means, right? So now we see that this is the y-intercept is right there. It's crossing the y-axis there. So here's our line, by the way. This is the linear equation. It's not exactly a straight line because I'm hand drawing everything. Remember that from the guaranteed pass notes. So anyway, we have the y-intercept there, and that's where it crosses the y-axis. Now you know what the x-intercept is? If this is the x-axis here, right? This is the x-axis. Guess where the x-intercept is? It's right there as well. So you know what that means? That's the x-intercept. And we're going to find something out pretty interesting. You know what the x-intercept is? If the y-intercept is when x equals 0, guess what the x-intercept is when y equals 0. Whoa! What? That's also interesting. So take a look at this little bad boy. Excuse me, that's also interesting. Because when y is 0, now we know the x-intercept. I find that interesting. So we have that little note. That's a cool note, cool to operate under. So there's the sketch of the graph, right? We had our table because we know it's a straight line, and all we're doing now is as the instructions go back to read, identify the x and the y intercepts, and we're going to identify each one in an ordered pair. So if, according to this graph, the y-intercept is when x is 0, that means the y-intercept is 0, 0. Also called the origin. So if some of you are asking, can I write origin? The answer is yes. Yes, you can. So the y-intercept is when x is 0. Right, so notice the y-intercept is when x is 0. And it's at 0, 0. And the x-intercept then is also 0, 0. Wow, my Facebook is blowing up. Can you hear it? And the x-intercept is when y is 0. And that's how that works. Right? So we can go a little bit quicker with some stuff now that we know some of the basics. We can make a table. We don't need 5 values. We can, we could use 2 or 3. And we can set our y-intercept for making x equal 0, and we can make our x-intercept by setting y equals 0. So in future tables, you're going to see me do this. And that way you can find out that's the y-intercept. So hopefully that's cool. We've sketched the graph. We've identified the intercepts, and we're doing some basic functional analysis. And now we're ready for that second equation, right? So now we're going to graph negative x plus 10y equals 11. And this is going to make some interesting stuff. So we'll see in a second. All right. So for there, we're going to make a table again. I've said it's a linear function, so we don't need anything tricky. Okay. But what values for x am I going to pick? And here I'm going to do a little bit of investigation. Can I use negative 2 and positive 2? Yeah, I can, but I'm not going to. I can, I'm just not gonna. And you might ask why. Because I'm going to go ahead and predict the future. I'm going to predict the future. My prediction, what do you think I'm going to do with any number that I use for x? I'm going to divide by 10, right? So I'm going to be dividing by 10. So I want to use something that will be helpful for me that I will divide by 10. So the first thing I'm going to do is I'm going to add x to both sides, and then I'm going to divide by 10, right? So what can I do with this 11 out here where I divide it by 10 to make it useful? So I can think ahead of some stuff, right? What can I add to 11 to make it a good number? If I add 9 to 11, that would be great. So why don't I make x equal 9? Because if x is 9, negative x is negative 9, I'd add 9 to both sides. That would be helpful. And I can also use negative 1. So I'm using good predictive, I'm going to be using good predictive x values. So use some good x values, and you'll see why in a second. Now I'm also going to have my intercepts, right? So I want x to be 0. That's my y-intercept. And I want my y to be 0. That's my x-intercept. And I can totally do that. You're going to think, well, that's a weird table. Yeah, it is. But again, I know what I'm doing. And if you don't, you're going to come up with some crazy numbers, which is fine. It's still going to make the same line. You're still going to have to find the x and y intercept anyway. So I'm not going to use negative 2, negative 1, all that stuff. I am going to use negative 1. But I'm going to pause. I'm going to predict so I can use some good x values, like 9 and negative 1. So why is 9 a good x value? Let's take a look. When we're substituting, we only substitute the variable. That x stays negative. We're going to be calling it negative 9 plus 10y equals 11, right? Now I'm going to solve for y. And I do that for a good reason, right? You'll see in a second. This negative stays. Notice how that occurs. So you got to be careful with that. That negative stays, man. So that's helpful. And you'll see that in the next one. So I'll have negative 9 plus 10y equals 11. I add 9 to both sides. Y equals 2. Isn't that a handy ordered pair? That's much better than some crazy number, and all that stuff. But it's just the power of prediction. Do you have to? No, you don't have to. You can use whatever you want. Anyway, on to the next one. So what if x is negative 1? Here, again, be careful. This negative from the equation is going to stay there. Okay, so that negative stays negative. The only thing I'm substituting is my x. Right? X is going to be negative 1 now. Notice how everything works with substitution. So now I'm going to find out what y is if x is negative 1. So now we're going to simplify that. Guess what negative 1 is? Positive 1, right? So positive 1 plus 10y equals 11. Subtract 1 on both sides, right? And look how pretty that works out. Ta-da! So that's kind of neat, I think. So if x is negative 1, y is 1. That's useful. Yes? Yes. All right, so now on to the intercepts. So how do I find the y-intercept? Well, if x is 0, guess what's going to happen? If x is 0, you know what I can do? I can do this. I'm just going to cover up my x, and I know I'm just going to divide both sides by 10. So automatically, without even looking, I know my y value is going to be 11 over 10. So what's going to happen? So you can see what's going to happen and start going quick. And the same thing, for the x-intercept when y equals 0, I'm going to cover up my y. And if I have negative x equals 11, then negative x equals 11, then positive x equals negative 11. So I already know that my x value is going to be negative 11. I'm ready to graph. Right? So I have my x-intercept, my y-intercept. So that's how that works a little bit quicker, hopefully a little shortcut for you. But let's graph this bad boy, and now we're ready to answer all the questions, right? So I know for my x values, I have to go out to 9 and then negative 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out to negative 11. 3, 4, 5, 6, 7, 8, 9, 10, 11. And then my y values, I don't have to go up or high or low that much. So I'm not going to get there, right? So I'm ready to sketch my graph. So I know if I have x is 9, y is 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. I know I have negative 1, 1. And I know I have negative 11, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, we're out here. So negative 11, 0. Okay, so here are my 3 points, right? But I also have 0, 11 over 10. What does that mean? And I'll show you that in a second. So there's my line. That's a rough estimate. Now, where in the world is 0, 11 over 10? 11 over 10 is a bit more than 1, right? So if that's a bit more than 1, does that jive with the graph, right? So if x is 0, y is a bit more than 1. Take a look at that. Checks out, right? So that's kind of a neat way to look. So there's my graph, and I can easily see from my table of values that my y-intercept, when x is 0, 11 over 10. Since my y-intercept is when x is 0. And my x-intercept is negative 11, 0, because my x-intercept is when y is 0. So I've answered that question. So far, so good? Awesome. Now, check this noise, because the last two are pretty sweet. So how in the world are we going to graph equation C? Well, we've got to remember from that previous video, f of x is the same thing as y. Right? You got to remember that. So f of x is the same thing as y. So if we have f of x equaling 4, it's the same thing as saying y equals 4. Now we know it's going to be a straight line, so I don't need a whole bunch of other stuff. And if you watched my guaranteed pass notes, you already know what this is going to look like. Otherwise, we got to do a little bit of thinking. We make a table of values, and guess what? It says y equals 4. That means in my table of values, I'm being told that my y equals 4. It doesn't matter what my x values are. I can just make up stuff because it doesn't matter. I can't plug that in, so it doesn't matter. And if that is confusing at all, please go watch the guaranteed pass notes that are there, all about graphing everything, like different graphs and all that stuff. And so you can tell. And if you remember anything, this is going to make a horizontal line. You can already tell that as well. So we can already tell it's going to make a horizontal line. And we're going to talk about intercepts in a second. So we have in the x coordinates aren't going to go much past 2 and negative 2. And then the y coordinates is going to go up to 4. I'm not even going to graph the negative ones because I know all my y coordinates are 4. So we have negative 2, 4, which is up here. We've got 0, 4, and 2, 4. And again, as we know, we're making a horizontal line, right? So there's the sketch of the graph. It's an important graph. Horizontal lines are very important. And so we have our horizontal line. So what does that mean for x-intercept and y-intercept? So remember, our y-intercept is when x is 0, right? And remember, the y-intercept is where the graph crosses the y-axis. Take a look. Ba-bam! It's crossing right there. So the y-intercept is at 0, 4. So where's the x-intercept? So the x, where's this graph going to cross the x-axis? It doesn't. It doesn't cross the x-axis. So what does that mean for the x-intercept in order, right? How do I find the x-intercept in order pair format? Well, if there is none, guess what? There is none. It happens. So it happens for horizontal lines. Isn't that cool? Totally cool. So we've sketched the graph. We've identified the x and y-intercept. On to the last one now. Right? And the last equation is equation D. We said x is equal to 2. It's the same thing. If you have a hard time seeing what's going to happen, please go watch that guaranteed pass notes. Those things are awesome. But I already know that my x is going to be equal to 2. So what does that mean for the table of values? It means my table of values, my x is already set. It's set at 2. And it doesn't matter what my y values are. Okay, so my y values could be negative 3, 0, 3. Why not? So I have these for my y values, and I'm ready to go. And again, from the guaranteed pass notes, if it's x equals, we already know it's going to be a vertical line. And notice how if we wrote f of x equals 4, that's a function. Functions are horizontal. We can't write f of x equals 2 and make it a vertical line. It's impossible because f of x is the output, right? It's the same thing as y. I just find that neat. You should too. All right, so my x values. You know my x values are going to only go out to 2. Done. My y values are going to go up to 3 and down to negative 3. Okay, so that's all I need to know for graphing. So I have an ordered pair at 2, negative 3. I've got an ordered pair at 2, 0, and at 2, positive 3. Check it out. Vertical line. Ta-da. So everything that we saw before seeing it is what we're seeing. How do you like that? Everything we saw in our heads before seeing it is exactly what we're looking at. Isn't that weird? So we have our situation here. Now we just got to identify the x and y intercept. So the y-intercept is where this graph is crossing the y-axis. Does it cross? No. So guess what? There is none. Ta-da! And the x-intercept is where it crosses the x-axis. And the x-intercept is where it crosses, or when the y is 0, so it's at 2, 0. How cool is that? So there it is, your graphing and your x and y intercepts. So that's how we graph. Again, we're using a table of values, and we can use the guaranteed pass notes. There are other ways to graph linear functions. We'll get more into that later. But this is enough for now. As long as you can see pictures and you understand relations and input and output and all that stuff, that's the point. So anyway, that's the recap. Remember what we did. We were graphing linear equations. I'm already telling you they're straight lines, so we don't need a whole bunch of points. We're sketching the graphs, and then we're identifying intercepts in order pair format. I'm out.